This is the first question that we're gonna try out, right? Shazay, Scotia, you guys did this one?
Yeah, I didn't like that one.
Yeah, this one is a bit tricky, right? This one is a bit tricky, right? So in the diagram below, M is the midpoint of ON. I'm not gonna read anything again. ON, M here. So they're telling me that this is in the middle of ON. Right? So OM is equal to a half of whatever ON is. Right? So that is one thing. You see, all of those conclusions I made without even reading the rest of the question. Right? Sketch the diagram above in your answer booklet. So I'll pretend to draw this over here. And insert the point X on OM. So I have OM and I have a point X on OM such that OX is a third OM. Alright, so I guess that point X will probably go like here, so right? You know, so if I split OM into 3 pieces, right, this is X here and this is 1/3 of the entire thing. Yeah, so I'm guessing that that is what X is going to be, a third of the whole OM. Produce PX. What? Produce PX to Q. Such that, oh, I see. Produce PX, so PX is supposed to be a straight line. That is not good. Alright, so I'm producing PX there. But to Q, where is Q? Who is Q? Such that PX is 4 times XQ. So PX is 4 times XQ. So that means PX is 4 times XQ. So that means that Q is going to be on PX. Right? So XQ is going to be about here. This is going to be Q over here. And why I say that is because XQ is going to be a quarter of PX. PX is really 4 multiplied by XQ. So XQ, 1, 2, 3, 4. Right? So this here is the point Q. Okay? And you see how I just kind of repeating things in my mind because I'm not sure what they mean, right? Where is the point Q? Well, PX is 4 times, so PX is going to be longer. 4 times XQ. XQ is short one here. So this is XQ and this is PX. Right? PX being the long blue one here. So Scotia, Shazay, did you all get this diagram so far?
No.
No, sir.
No? So you had Q on the outside somewhere? Shazay, what did you get? What did you have? What did you do wrong?
I didn't write anything more PX to Q because I didn't understand how it works.
Right. Do you understand what I did now?
Yeah.
Does it make sense?
Yes, sir.
Now at the end, sorry, Scotia?
I just had X. I didn't pick Q.
You couldn't figure out where Q was?
Yeah.
Alright, yes. Some people would have said Q would have be outside all the way over here. And because they would have think that PQ is 4 times PX. But PX is the longer one because it is 4 multiplied by whatever XQ is. So that means XQ had to be the shorter one. right? So really and truly is the understanding of the algebra here, right? But you see, Shazay, how I read in the question literally one word at a time, right? I'm trying to understand every single word, yeah? And this is how you should literally take one word at a time, right? So write the following in terms of R and S. So I see this is R and this is S, right? So no problem. We had a question like this in class already, so this should be okay, right? OM. So I want OM in terms of R and S. OM is here. OM is here. So wouldn't OM be OP plus PM? So OM is OP plus PM. OP plus PM, and the arrows are pointing in the right direction as well, yeah? So we could see here that OP is really R and PM is really S. So therefore, OM is equal to R plus S. Now let's look for PX. PX is here to here, and I'll do it in red. PX goes in this direction. All right. So PX, I could say, I could say PX is, I could say is PO plus OX. Right? And yeah, I could say that PX is PO, so going in this direction, plus OX in this direction. Yeah? So Shazia, you all understand that? Scotia plus OX. Right? So Scotia and Shazia, you all okay with that so far?
Yeah.
Alright.
Oh, I thought you had to use the S.
You what?
You didn't have to use the other S.
Well, I haven't reached there yet. So let's see.
Oh.
Let's see. But you understand how I reach here, right? You understand my reasoning?
Yes, sir.
Now, I don't know if this is correct. And I notice here that I'm not really around anywhere around S, right? So I'm noticing that. But so I don't know if this is correct, but I'm just talking about my simple little knowledge of vectors that we learn in class. And in terms of the triangle law, to get from P to X, I could drive from P to O, and then I could go O to X. Or I could drive from P to M and go MX. So you could do any one. But you understand what I'm talking about, right, Shazay?
Yes, sir.
Right? So let's see if my way helps or does anything. PO, well, OP is R, so PO going to be minus R because it's going in the other direction, right? Plus OX, well, we see here that OX is really a third of OM. So OX is a third of OM. And look, we have OM up here. So therefore, what do I have how? No, negative R plus a third of OM, which is R plus S. That means that I have negative R plus a third R plus a third S. So that means that if I have 1/3 minus 1, what is that? Minus 2/3? 1/3 minus 1. That's minus 2/3, eh? Yeah. So now I have 1/3 S minus 2/3 R. And that is PX. How will you feel about that, Scotia?
Yeah.
And you're seeing here that what I did is nothing outside of what we did in class, eh? Yeah? It's just basically recognizing the triangle law of how things flow in. And that's what vectors is about. It's about the direction of how things flow in. Caitlin, how are you understanding this right now?
I don't know, I have negative r plus s.
Plus s. And what's your reasoning for that? How do you get plus s? Because negative r means you're going back in this way. And plus s, where does s come in? Does that mean that you're driving? Remember, when you think about vectors, a way to think about driving, right? So tell me, Shazay, how were you thinking about it?
Well, to be honest, I was just trying to make sense of them saying in terms of r and s.
Right.
Because I thought you had to use s alone.
But you see here that that we did use s, and
Yeah.
yeah, we absolutely did use s. And just because the route that you take, is literally, you just pretend like you're driving. You want to go from P to X, but you can't pass on this road, so where you go pass? You could pass PO, and you could pass OX. Or, and if you guys want, and I don't want to confuse you all, but do you all want to try to see if we could do it this way? PM plus MX.
Yeah.
Right? So PM, let's see if we could do it that way, right? And see what we get. So PX is equal to PM plus MX, right? PM is S, no problem, plus MX. What is MX? They tell me here OX is a third of OM. So what is MX? They say here OX. Look at how they expressed OX. They expressed it in terms of OM. OX is 1/3 of OM. So if I wanted to talk about MX, what would I be talking about? Yes, that is it. Because this is not hard and you guys are overthinking. You guys are thinking too much, right? So yeah, it would be 2/3 of OM, right? So it'll be 2/3 of OM. My problem is, the direction, right? Because XM is 2/3 of OM. And yeah, MX would be 2/3 of OM as well. But my problem is the direction. I think that we might have to put a negative. Let me work it out normally and see, but we might get this wrong, because of the direction, right? So let's check it and see if we get it wrong. This will be S plus 2/3 of OM, which is 2/3 of R plus S. So that gives us S plus 2/3 R plus 2/3 S. Right? Yeah, you see, we're really supposed to minus it. Yes. So up here is supposed to be S, and then we add in MX. MX is here to here, is in this direction, right? But OM goes in this direction. So we'll have to minus OM because we're going in the other direction. So we minus in 2/3 of OM, right? So now we'll get S minus 2/3 of R plus S, which is S minus 2/3 R minus 2/3 S. S minus 2/3 will give us 1/3 S minus 2/3 R. So you, sorry, somebody has some feedback there. Well, we were hearing you just now, but we're not hearing you anymore. So I don't know what's going on, but hopefully you sort it out, right? So you see here we got the same answer, but it was important that we had put this minus sign here. And you understand, Shazay and Scotia, do you understand why we had to put that minus sign there? Yes, because it went in the other direction. We was going in this direction when the vector was actually, OM is actually going in this direction, right? So Shazay, do you understand what we did here? All right, and do you see, Shazay, that what we are doing here is nothing more than what we did in class, eh? It actually pretty easy. It doesn't require any genius level or any kind of thing, yeah?
Yeah.
Right? So this is why I really say really pay attention to the stuff we do in class and think about it simply. Think about what you know. Don't try to invent new things. You see the cheat sheet? The cheat sheet. When you have 9 or 10 things on that cheat sheet, that represents what you know. So when you read the question, you are supposed to check it against the cheat sheet. This cheat sheet is supposed to be in your mind. You're supposed to know it by heart. And when you check it against the cheat sheet, this is the list of all of the things that you know about vectors. And the question is supposed to fit inside of this list somehow. So you can say, well, okay, maybe I could try triangle law. Or maybe I could try scalar and see what works, you know? So it all has to do with what you already know. So you don't have to invent anything. Just think, what do I already know? That is the first thing that you should always be thinking. Right? They're not going to ask you anything that you do not already know. So yeah, the point is, yo, don't overthink now. Everything easy. Everything easy. Just take your time. Move slow. If you move too fast, you'll confuse yourself and end up spending more time. You know? So we have QM to do again. So we have QM now. Right? So QM, look, I rub off this, right? So this here is X. This point here is Q. And I want from Q to M, which is here. QM, I want to go in that direction. So I'm starting from Q and I want to go to M, but the road block. So Shazay, can you tell me a next road that I could use to reach M? Very good. It's as simple as that. Q to X and then X to M. So let's try that. I don't know if that's correct, eh? I don't know if that I might end up with a whole set of hard thing, but to me that looks like the shortest route. I could have go Q to P and P to M, but that looked like a lot more driving. So let me take the shortest route, right? Q to M is Q to X plus X to M, right? So how can I express Q to X in terms of R and S? What is Q to X? Anybody want to help me out?
Quarter of P to X.
Like a boss. Yes, it is. And you could plainly see it with your eye. P to X. Q to X is a quarter. So Q to X is a quarter PX. Alright, sorry, I write a half there, but I meant to write a quarter. Right? It's a quarter PX.
Wait, how's the quarter?
Right, so you could see here that they say here PX is 4x XQ, right? You seeing that? And they got their and this is why I hate CSEC, right? Because they should have said PX, because PX going in this direction. So they should have said it is 4 times QX. Yeah? So that is really the correct thing. So CSEC just write a set of dotishness there. Because they could confuse you with direction with writing it like this, right? So we could see here that what do we want? We want Q to X. We see here that PX is 4 times QX. So therefore QX will be a quarter of PX. You understand, Scotia?
Yeah.
Right. So we have a quarter of PX here. And then what is XM? XM, we had XM up here. XM, somewhere up here we had XM. Oh, that was the one that we did just now. Remember, XM is 2/3 OM. Yeah? That's how we get XM. You understand that, Scotia?
Yes.
Right. So now we have a quarter of px. Look, we got px here to be this. So a quarter of a third s minus 2/3 r plus 2/3 om, which we got to be this, r plus s. Alright, so we look like we have a whole bunch of stupid looking things there. A quarter multiplied by a third, 4 3s are 12. That is 1 over 12s. Minus a quarter over 2/3. A quarter multiplied by 2/3 is 2 over 12, which is 1 over 6. I believe. Please correct me if I'm wrong, right? I'm a calculator lady, right? Plus 2/3 r plus 2/3 s. And so the final answer will be, oh my goodness, what is 2/3 plus 1/12? 2 over 3. I could do it the brain way, you know. Plus 1 over 12. That is 3 over 4. So 3 over 4s. And then 2/3 r minus 1/6 r. Thanks, calculator lady, for being so helpful. Is a half. That's plus a half actually. So apart from working with some messy fractions, we get 3 over 4s plus a half r. How do you feel about that, Shazay? So, Pn is equal to 2pm plus op. Caitlin, let me hear you. All right, where is P to n on the diagram?
From P1 to N.
So that means that you had to draw this, right? So this is what they're talking about, P to n, right?
Yeah.
And they're saying that it is equal to 2 times pm. Well, I see in pm is here, right? Plus op. Op is here. That is interesting. That is interesting, right? So all I know how to do, I just know what I learned in class. And Sir teach me triangle law in class, right? So let me try to find Pn, right? Pn is Pm plus Mn. Would you agree?
Yes.
Is Pm plus Mn, right? And Pm is what? Pm is S, right? Plus Mn. Mn is what? Can anybody tell me in terms of R and S what Mn is? Remember they say M is the midpoint. You know, look at the things that you know. Give me Mn in terms of R and S. Remember, simple as possible. And what did they tell you here? That they started off by telling you M is the midpoint of ON. M is the midpoint of ON. So what does that mean? Mn in terms of R and S. You know that M is the midpoint of ON, and?
Yeah.
And you know OM?
Yeah.
So it's easy, it's so easy. You'll go pull out on yourself, man. Stop thinking so hard. Shazay, stop thinking so hard. M is the midpoint of ON. Wouldn't that mean, what does midpoint mean?
Middle.
Middle. And what does middle mean? You're cutting it. Divide by 2, right? So ON being divided by 2, which means what? Doesn't it mean that this half is equal to this half?
Yes, sir.
So doesn't that mean that OM is equal to MN?
Yes, sir.
You understand that, Scotia?
Okay.
So MN is actually just OM. which is R plus S. So Mn is R plus S. Alright? Alright, and if you want, you could write here because Mn equals OM. Use what you have. And look at that. Just that midpoint thing alone, I was able to figure it out. And now what do we have? We have 2S plus R. Yeah, 2S plus R. And if you look at it, we see here that 2 p.m. is, or I wouldn't write that yet. We see here that PM is really S, and yes, is it?
Yes,
So therefore 2 p.m. gonna be 2S, and yeah. And we saw here that OP is equal to R, and yeah. Therefore, this is 2 p.m. plus O. Proof. The diagram below, and this looks like one that is just like the other one that we did just now. This looks like one that's very similar. Not drawn to scale, shows the triangle JKL. M and N are points on JK and JL respectively. So JK have M on it, and JL have N on it. Alright, so let me see where, because I just put the sketch there, right? JM is a third of JK. So from here to here is 1/3. 1/3 the entire distance. Alright? And the same thing, JN, and let me just draw the N a little bit inside a little more. So this is the N here. This is also a third of JL. Alright? Scotia and Shazay, did you guys get this so far? Alright? Copy the diagram in the answer sheet below and show the points M and N. Nice. Good. Given that JM is U, so I'll just put that on my diagram. You see how I just read in piece? I am reading the whole thing. I just read in piece. JM is U. So JM is this one here. And that is U. Right? And, well, I gotta rub off this third because I know that the two of them is a third. So I gotta rub off the third and I gotta put the U here. Alright? And JN is V. JN is V. Right? Write in terms of U and V an expression for JK. Oh gosh, this is easy. Shazay, given that we just struggled through the last question, which was harder than this one, do you think you could understand this question now?
Yeah.
Alright, so do you think that you could give me JK in terms of U and V? JK.
In terms of one.
In terms of U and V, yes. When they say in terms of U and V, it doesn't have to have U and V, yeah? Sometimes it might just be U alone, sometimes it might just be V alone, you know?
Oh, okay.
You don't have to use U and V. And I see what going on here. Sometimes you just take these kind of words quite literally. Yeah? And you expecting that you have to use both. And at the end of the day too, that is a downfall in CSEC. Right? They should have put in terms of U or V or U and V or whatever. They should have been more specific, right? But you need to be careful when it comes to your interpretation of things. So JK in terms of U and V. Let me hear you.
3 times U.
Right, so 3 times JM, eh?
Yeah.
Which is 3U, and that is it. Alright? That is all. Alright? Now let me get Scotia with MN. MN. Ooh, MN is this guy. M to N like that. Alright, so Scotia, you wanna try MN? Well, tell me how you get that. Don't give me the answer. You had to tell me this one first. All right, no. Mn is not Jm plus Jn. No. Because Mn means I'm starting by M and I'm going to N. And Scotia?
Yeah.
But the road get blocked, and Scotia? So that means that if I'm starting by M and I can't pass on this road, that means I had to go so and then come back so and. So that is Mj, not Jm. It is Mj plus Jn. You understand where you did wrong, Scotia? Right? And not only that, but remember, these two J's kind of cancel. You're supposed to have the answer Mn on the outside there. So you understand where you did wrong there, Scotia? Yeah?
Yeah.
So you'll see here that because of that, Mj is actually minus U plus Jn, which is V. So therefore, the answer here is V minus U. And you would have V plus U. So you had to be real careful about that, Scotia. You understand? You can't just go add in. You actually have to, when you see this M to N, you actually have to think about it like you're driving from M to N. Yeah? And KL, well, KL is for Caitlin. So Caitlin, give this one a shot. KL is this guy here. How can I express that in terms of U and V? Are you there? You hearing me?
Yeah.
Alright, so first of all, Caitlin, I want to drive from K to L, but the road blocked. So right now you are at K, and you want to drive to reach by L, but this road blocked. So how would you pass? Come on, Caitlin, stop being afraid to be wrong. It's okay to be wrong. Say something.
From K to G, right?
Yes, so K to G, and then what? From J to L, eh? Very good. So K to L is equal KJ plus JL. And you see we use the triangle law, which means these two J's cancel and you end up having KL on the outside there. You understand that, Caitlin?
Yeah.
Right. So now I want KJ and JL in terms of U and V. You think you could tackle that? What is KJ in terms of U and V? Well, yeah, well, JK, yes, you're thinking correct. But here what? You're thinking correct, but you feel you're wrong. So because you feel you're wrong, you're trying to overthink your correctness. And oh gosh, relax now. Geez, you're correct. But you know from here that JK is 3U. So therefore KJ will just be negative 3U. That's all. You understand, Shazay?
Yes, sir.
So stop overthinking, man. You're thinking too much, right? And Scotia, what is JL? Why do you think is minus V? Because aren't we going from K to J and in this direction, right? And then we're going from J to L in this direction. Isn't that what we're doing, Scotia?
Mm-hmm.
Right? And nth J to N in that direction, that V in that direction. Isn't that V positive?
Yeah.
So aren't we going in the same direction as positive V?
Yeah.
So it wouldn't be negative. You understand that, right? Right? Do you see here why this one was negative? What sign changed? Not because the sign changed. Yeah, because this direction is where the direction that positive U is going in. And they told you that. And the answer to all of your questions is right here. Right? They say that JM is not, don't just think about J to M as a line JM, you know. I want you to think about it as a direction J to M. That is the direction U. And that is positive going up. So if you're coming back down, that will be negative. You understand that, Scotia? You sure? Right? So yes, you're on the right track. It's going to be some positive V, right? Not negative, because we're not going in the other direction. We're going with the arrow, so it's positive V, right? So because it's positive V, right? But then you say you don't know how much V.
Yeah.
But do you want to change that now? Because all of the answers are right in front of you. Come on, Scotia, come on. This is elementary stuff. This is not a big thing. You're overthinking it. Look the answer right here. And you can visualize it too. How much is this, Scotia? A third, right? So that means that this line is separated into 3, yeah? So how much V is it going to have? 3V. You understand? Right. And it's all about how, I think one of your problems, Scotia, is when you see MN, you thinking that is just a line between 2 points MN. And you not thinking about the fact that this is the direction from M to N. Right? In terms of driving. So this here means that you're driving from M to N. And you need to keep that in your mind when you're doing vectors. So this here, the answer here, ends up being 3V minus 3U. Or we could say it's 3 into V minus U. Right? So that KL is actually 3MN, because MN is V minus U, right? So, well look, they ask us that in the very next question. But before we do the very next question, Shazay, Scotia, you all okay so far up to this point? Using the findings in B2, this is 2, right? These findings here, right? Deduce 2 geometrical relationships between KL and MN. So KL and MN. So look, this is MN and this is KL. What are 2 geometrical relationships? Look at it. MN is V minus U and KL is 3 into V minus U. So what are 2 geometrical relationships that we could remember? Just check your cheat sheet, Dred. Everything on your cheat sheet. Everything is on the cheat sheet. So somebody tell me this one. 2 geometrical relationships, huh? They are parallel, yes. MN, which is this guy, and KL, which is this guy, are parallel. So number 1, they're parallel. Right, where's another one? Right? Actually, the first one, the second one should have been the parallel. The first one is you're supposed to state that MN KL is equal to 3 times MN. So therefore they are scalar multiples. That is the first geometric relationship. And then the second geometric relationship, because they are scalar multiples, means that they are parallel. Alright, you could see here, guys, that everything that I'm doing is just those things we did in class. Nothing more, nothing less, right? We have a few more here to do again. So let's see how we run in this one. The graph below shows 3 points, P, Q, and R relative to the origin O. Well, you see, I see origin O, so I automatically start to think position vectors. That is what I automatically start to think, right? Write as a column vector of the form XY, okay. First is OP, well, I see here from the origin O, OP, so that is a position vector from the origin O. So OP, this here is P here, is from O, 1, 2, 3, 4 on the horizontal, minus 1 on the vertical. So it's 4 minus 1 OP. Shazay, did you do this one?
Yes, sir.
All right. So QR, and this is probably more like the kind of question that you might get, hopefully, right? QR. Well, QR is not a position vector at all, is it? Right? QR is not a position vector at all, but QR from here to here. I could do triangle rule and thing, yes, but they gave me a nice gridded graph. So I could just use the graph 1, 2, 3 on the horizontal, and then 1, 2, 3, 4, 5 on the vertical. So 3 on the horizontal, 5 on the vertical, 3, 5, and that is it. You guys got those?
Yes, sir.
Lovely. Determine the magnitude of QR. Well, simple. Magnitude of QR is equal to the square root of 3 squared plus 5 squared, which is the square root of 3 3s and 9 plus 5 5s are 25, which is the square root of 25 and 10 is 35. So 25 and 9 is 34. This is the square root of 34. All you do it and nobody can tell me the answer. I had to do it myself, Dred. 5.8. I made any mistakes here? Tell me if I made a mistake. 3 3s are 9 and 5 5s are 25, right? 25 plus 9 is 34.
Yes, sir.
Alright, good. Nice. So Scotian should say you all got that? 5.8?
I just had a little stretch.
Yeah, but that's small. So you get this, right?
Yeah.
Alright, that is cool. Very good. So far, at least. Alright. On the graph provided on page 33, draw the vector OS, which is 7, 4, and show that PQRS is a parallelogram. Right? So the vector OS is 7, 4. So, oh no, why? So the vector OS is 7 on the horizontal and 4, 1, 2, 3, 4 on the vertical. So that is the point S, 7, 4. And that there is the OS. So OS is this. Right? And they tell me the vector OS on the graph provided, draw the vector OS 7, 4 and show that PQRS, you notice O have nothing to do with this, eh? Right? So draw the vector OS. Okay, I drew the vector OS, but thank you for making my diagram look stupidly complicated because I don't need that for the next part. PQRS. Alright, this here. Show that PQRS is a parallelogram. How can I show that PQRS is a parallelogram? Stop overthinking. You have pretty much half of the answer in the question itself. Shazay, how do I show that PQRS is a parallelogram?
Yeah.
In order for it to be a parallelogram, that means that this has to be parallel to this, and that means that this has to be parallel to this. So, is there any way to show if QP is parallel? So QP, and this is how we write parallel, to RS, right? And we have to show that QR is parallel to PS. And what in the cheat sheet do we have to show what do we do to show that two vectors are parallel? What do we have to do? Anybody? Dread, we just do it in the last question, you know.
Yeah, to show that there are multiples of each other.
Yes, we have to show that they are multiples of each other, right? So if we check vector QP is this, right? QP is what? 1, 2, 3, 4, and then 1, 2, negative 3. So QP is 4, negative 3. Let's check RS. RS is 1, 2, 3, 4, 1, 2, negative 3. RS is also 4, negative 3. So not only are they multiples of each other, but they are in fact equal. Would you agree, Scotia? And if they equal, would you agree that that means that equal vectors go in the same direction? So then they parallel, eh? Would you agree, Scotia? Yeah, so you can see that if two vectors are equal, they are parallel. And yes, they are scalar multiples of each other because QP is 1 multiplied by RS. So they're equal. And they do have scalar multiples of each other. Right? And we could see here QR is 1, 2, 3, 1, 2, 3, 4, 5. So QR is 3, 5. Right? And PS is also 3, 5. Right? 1, 2, 3, 1, 2, 3, 4, 5. So therefore, QR is equal to PS. Therefore, parallel. Hence, this is a parallelogram. And you see what I did? I used the words. The words are the clues. And Shazay was on the right track because Shazay looked at the word parallelogram and Shazay automatically thought about the parallelogram law. But then when you go and you try to think about the parallelogram law, you realize, well, maybe it doesn't really help us here. But look, the word parallel is a big word. Forget about ogram. This word parallel is what really helped us. Because a parallelogram, the sides must be parallel. Now, the points A, B, C have coordinates. Those are the coordinates. Well, let me sketch it on my little sketch diagram and see, right? So I could just sketch here. I'd like to see what things look like. I could see that, well, A is negative 2 on the X, right? And then 8 on the Y. 1, 2, 3, 4, 5, 6, 7, 8. So this here is the point A, negative 2, 8. And you notice how I've taken the question piece by piece. The point B is 4, 2. So 4 on the X, 1, 2, 3, 4, 1, 2. So this is the point B, 4, 2. And I don't even know if this diagram will help me or confuse me, but that is all I know. C is 0 on the X. So C stays there, but it is 9 on the Y. So it will come 1 higher than A. So C will be over here. C is 0, 9. Right? So I have my points here. A, B, C. Alright. Express each of the following in XY. OB. So this is O. Right? And Scotia, you start us off. What is OB? Vector OB in this column vector form here. Yes. 4, 2. Thank you very much. Alright. So OB is 4, 2. AB. What is the vector AB? What do you think the vector AB is going to be? This one here. Scotia, any ideas? I mean, you could do all of that. You don't have to do all of that. And how, whoa, first of all, how is A, B going to be A plus B? Are you trying to tell me that the vector AB is equal to A, the point A plus the point B? Is that what you're trying to tell me? Yeah? Scotia?
Yeah.
And don't be afraid to be wrong, Scotia. It's okay if you're wrong. Scotia, I just sound like I'm buffing all you.
Not really.
Not really, so that means I just sound like I'm buffing all you, kinda. Right? So what you're saying is A plus B, and you have to be careful about these kind of things. I mean, I could understand why you say this, right? But no, the point A is negative 2, 8. And the point A needs to be added to some vector in order to be translated to the point B. You understand what I do there? Right? So at the end of the day, you can't just add the points A and B. Right? It's the point A that is moving in a certain direction, and that direction is what we want to find out. That is the vector. And then it'll end up by point B. So you can't just add A and B. And I'll tell you something, Scotia, I want you try again, but the answer is much simpler than that. The answer is much simpler than that. You can literally read it off of the sketch here. Wow, no, simpler than that. You're overthinking, Scotia. Right? Remember, what is a vector? A vector is xy. X being how much horizontal spaces you move. Y being how much vertical spaces you move. And I mean, yeah, you could say AC plus CB. That is not wrong, Scotia, but that is, you're definitely overthinking there. Think simpler than that. Simple. Is you want to go from A to B, right? So you have the point A and you have the point B, so you have all the answers that you need. Let's look at the x value first. Negative 2 to 4. So in order to go from negative 2, which is here, and reach by 4, you have to go what? 1, 2, that is negative 2 there, and then 1, 2, 3, 4 on this side. And Scotia? So you had to move 6 spaces on this side, huh? Yeah, so 6 on the horizontal. And then we'll look at the vertical here on 8, and you had to go down to 2. So you had to move 6 spaces going down, eh? And 6 spaces going down gives us negative 6. Eh? You understand?
Yeah.
Now, it have another way that you could do it, and the other way was what you were trying to do. AB, the vector AB, right? Really and truly, the vector AB is that this is what this translate or move A to B. Yeah? So I have the point A plus the vector AB will give me the point B. Right? So if I take the point A, negative 2, 8, and I add in the vector AB, which is some xy that I don't know, I will get 4, 2. Right? So this is the adding thing that you was thinking about, where you have the point A and you're adding a vector to it. So that means that this vector is going to move those points and carry it down by that. And now you could think, well, negative 2 plus what will give you 4? Well, x gonna have to be 6. Right? And 8 plus what will give you 2? Well, that is negative 6. You understand, Scotia?
Yeah.
So you see that the easy way was to just look at the sketch and figure it out. And if you really wanted to overthink, this hard way here is you know, and this is not the only way. Yeah, we could have done the other suggestion and gone A, C, and C, B. You know, we could have do all of that and we would have get the same answer. But really and truly, look, the sketch here, I was able to just read it off. Look, you have all of the points. So when you have them points, that's all the info you need, right? So Scotia, let's see if you could do OM. Right? M is the midpoint of the line segment AB. So AB is here, so M will be somewhere in the middle, and I want OM. Right? Now I don't know from this sketch if M is actually on the axis or if M is off the axis. Yeah, I don't know, right? But how do you think I could find OM? Yes, you're on the right track, right? But I want to explain why. Can you explain why? Because if I divide this by 2, right, then really and truly what's happening is when you divide this by 2, you're finding the point M. And remember, the point M is really the vector OM. Every point is a vector from the origin. That is what a position vector means. So really and truly, to find the point M, you could do it a couple of ways. You could do it the coordinate geometry way, right? We could take A, B, and we could find x2. Remember, the midpoint M is x2 plus x1 over 2, y2 plus y1 over 2. So we could do it this way, but we probably wouldn't get any marks for this way, right? We might probably get 1 mark, but let's see, right? X2 plus x1, that's 4 plus negative 2, right? Over 2. And then y2 plus y1 is 8 plus this here is 2 over 2, right? So this gives us 4 minus 2 is 2 over 2 is 1 on the x, so it'll be somewhere over here, right? And then 8 and 2 is 10 divided by 2 is 5 on the y. Yeah, so this is the coordinate geometry way, but you wouldn't get no marks for this, right? But let me look at the other way. The other way is, well, you know that AM, right, is really a half of AB, right? And so AM is a half of AB, which is 6, negative 6. So AM is really 3, negative 3. And so you could actually work out now, well, alright, so AM, this is 3, negative 3. So I could come on the graph and say, well, alright, if I, from the point A, I'm moving 3 spaces, 1, 2, 3, so that'll give me 1 on the x-axis. And then negative 3, so 8 minus 3 will give me 5 on the y-axis. So now I end up with 2.15 to be M. So M is 1 on the x and 5 on the y. So Scotia, do you understand these two different ways of doing it? You sure?
Yeah.
All right. So well, that was a good one. Shazay, you okay with this so far?
Yes, sir.
Now they say here, use a vector method to show that AC and OB are parallel. AC, which is this here, right, and OB, which is this here, are parallel. And let me just draw over the diagram a little bit nicer, because that is quite scrappy there. So let me just draw it over real quick. Negative 2 and 1, 2, 3, 4, 5, 6, 7, 8. So that is A, which is negative 2, 8. C over here is 0, 9. B is 1, 2, 3, 4, 1, 2 over here. B, 4, 2. And then I have O, which is 0, 0. Right? So what they want is they want you to show, using a vector method, show that AC is parallel to OB. How can I do that? And if we look at the vector AC, we can see that that vector is what? I'm on -2 and I want to reach by 0, right? So I had to move 2 spaces, 1, 2 in a positive direction. So that's 2 positive there, right? And then in vertical, I had to move from 8 up to 9. So that is 1 up movement. So AC is 2, 1. If we look at the vector OB, what do we get? The vector OB starts at 0 on the x-axis and it goes to 4, right, in a positive direction. So that means that it's moving 4 spaces on the x-axis. And on the y, it goes from 0 to 2. Right? So we can see here that the vector AC is 2, 1 and the vector OB is 4, 2. You understand this so far, Scotia?
Yeah.
Alright? So now we can see here that OB could also be, if I pull the 2 on the outside into 2, 1, right? So 2 times 2 is 4, 2 times 1 is 2. So you can see here this little vector inside of here is really AC. So therefore, OB is equal to 2 times AC, right? And because they're scalar multiples, hence they are parallel. You okay, Scotia?
Yeah.
Shazay, how are you feeling about this? The points A, B, and C have position vectors that, and that. Alright? Express in the form of XY, the vector that and that. Alright? Let me draw a little sketch for this. So OC is 12 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then -2 on the y-axis. 1, 2. So this here is the point C, which is 12 on the x, -2 on the y. OB is 3 on the x, 1, 2, 3, and then 1, 2, 3, 4. B, which is 3, 4. And then OA is 6, 2. So that is 1, 2, 3, 4, 5, 6, 1, 2. So that is over here. Right? So 6, 2. They're looking suspiciously collinear, but it could just be that. So this is A. It could just be that my diagram was drawn poorly. So whilst they're looking like they're in a line, they're looking like they're collinear, but maybe my diagram just drawn poorly. So I'll keep that in mind, right? And this is the thing, you know, you have to see things, and I guess it just boils down to you guys having to know your work and really, really know your work. Understanding is one thing, but to know it is another thing, and that's up to you. I could teach you how to understand the work, but I can't teach you how to know it. You have to know it, right? So express in form XY the vector BA. So we could use the same method here, B to A. You could see here that are going on the X are going from 3 to 6. So horizontally, I'm moving 3 spaces. So BA, horizontally, I'm moving 3 spaces. And then vertically, I'm going from 4 to 2. So I'm moving down 2 spaces. So Scotia, you understand that?
Yeah.
Alright, so you understand how I just use my diagram there to find it, right? So,
So when you ask you like questions like that in calculation,
what do you mean translate?
you have to
To get the answer, I just use my little sketch there, and I got the answer, and that is the answer I'm gonna put here. BA is equal to 3 negative 2. Right? Now, if you want, you could do vectors as a translation. So you know that from B to A, from the point B plus some vector will give you the point A. So B is 3, 4 plus xy will give you the point 6, 2. And we can see here 3 plus 3 will give me 6. And 4 minus 2 will give me 2. So I could have done it like this, yes, but getting it from the sketch is a whole lot easier. You don't find so? I will, it's a rule for me. If I don't have a diagram, like look in this one here, they give me a diagram. But this one here, they are giving no diagram. So it's a rule for me that I need to draw a sketch. Yes, Kosha? So where's the issue? Because what they gave me here is they gave me these position vectors. And I know position vectors are just points from the origin. So I went and I draw my sketch. And then from the sketch, look again, all the answers I want. And you understand, Scotia?
yeah.
Always depend on a sketch. You have any questions? Alright? So you would have wanted to use the translation vector as a translation. Yeah, it is what I did on the graph. Yes, it is. Right? It's pretty, and I'm glad, I'm really happy that you recognize that. I'm really happy that you recognize that. But look, drawing a graph is so much more informative, because look, I could see this looking like a collinear kind of thing before I even, before I even read the rest of the question. So I expecting, if this is drawn correctly, maybe there might be a collinear thing. And if it's not collinear, then I know that my graph I'll probably just draw it a little bit bent or a little bit twist. Maybe it's a really, really skinny little triangle like that. Maybe it's a skinny triangle. Or maybe they're all on one point line like that, right? So I don't know, but when I see the points lining up so nice and easy, I'm starting to think collinear. So you could see that when you draw your sketch, you don't find drawing a sketch a lot more intuitive and makes the process easier? You don't think so?
Yeah.
You guess? Yeah. Listen, not just vectors, Dred. Every single topic, draw your sketch. Draw your sketch, please, right? So BC, well, BC, I could do the same kind of thing, or I could do it Scotia's way. B plus some vector will give me C. So B is 3, 4, plus some xy is going to give me 12, negative 2. So 3 plus what will give me 12? 12 minus 3 is what? 9, 10, 11, 12. So therefore is 9 going to be the x. And 4 plus what will give me negative 2? 4 minus 6 will give me negative 2. And let's check here, from 3 to 12 is 9. And from 4 here to negative 2 is minus 6. So BC is 9, negative 6. You feel better about yourself there, Scotia?
Not really.
Not really, but you understand what I just do, right? You sure you understand? Because this is some super easy stuff, and to me it's sounding like if you don't understand. Yeah. State one geometrical relationship between BA and BC. So let's see. BA is 3, negative 2. BC is 9, -6. State one geometrical relationship between BA and look, part 3. Draw a sketch to show the relative positions of A, B, and C. Well, look at done, get my 2 marks there. So, ha, right? Ha. But tell me, what is one geometrical relationship between A, B, and C? Well, we definitely know if they're parallel, right? BA, let's just see, BC is, I could pull out 3, right? And then 3 3s are 9 and 3 by -2. So yes, they definitely are parallel. BA and B. But imagine if I have one point B, right? One point B, and I saying that BA is parallel to BC. That making any sense? So what if I put the C on this side? Is this making any sense? The only thing that makes sense is this, eh? And that makes sense?
Yeah.
So yes, they are parallel. But if you notice, when 2 parallel lines share the same point, remember parallel lines are never supposed to meet, eh? Parallel lines are never supposed to meet. So how can they share the same point? They could only share the same point if there's the same line. You understand? So therefore, yes, they are parallel, but one geometric relationship between BA and BC, well, where we could put the parallel, alright? But I also think that you should put, and you could put the 2 of them just in case you think one wrong, right? So they're parallel, and therefore A, B, and C are collinear.